So section 5.2, more exponent rules, okay? We learned the exponent in section 5.1, right? So a to the nth power equals what? A times a times a times n times, right? N times, okay? So in this section, we're going to talk about more exponent rules, okay? So first we'll do what? 0 as an exponent. Secondly, we'll look at negative number as exponents, okay? And then the third, we will use the quotient rule for exponents. And then number 4, we'll combine the rules for exponents, okay? So first, okay, let's look at the 0 as exponent, okay? So if we have a to the 0th power, where a does not equal 0, means a is any non-zero number, means a could be 1 or 2 or 3 or -1, -2 or whatever, but a does not equal 0. What is a to the 0th power? We define a to be what? 1. So remember this, okay? Eventually when you encounter, oh, what is 2 to the 0th power? What is it? It is 1, okay? What is x times y to the 0th power? What is it? It is 1, okay? Yeah. What is -11 to the 0th power? 1, okay? So if the base a is a non-zero number, its 0th power is always 1. However, how about a equals 0? What is 0 to the nth power? What does 0 to the nth power mean? 0 times 0 times 0, n of 0, right? So what is the product of n of 0 multiplied by together? 0, okay? So if base is 0, 0 to the nth power is 0. But if a is non-zero, the 0th power of a is 1. Okay, remember this, okay? Now let's try to practice, okay? Try to practice. So, let's look at question B. What is a to the cube times a to the -3? By using the...
Is it 0?
Yeah, it's a to the 3 plus -3. Remember the rule we learned from section 5.1, right? A to the 0. What is a to the 0? 1. It doesn't say a is 0. We assume a does not equal 0, okay? So a to the 0 is 1. How about -11 0th power? Do we get positive 1?
No.
No. Why? When we have exponent and multiplication, which operation should we do first? Exponent, right? So it should be negative of, what is 11 to the 0th power? 1, right? Now I'll give you another question. Oh, here, I don't have to give you that question, it's already given. This one, -11 to the 0th power, we have a parenthesis, right? So the a, base a is what? -11. Because of the parenthesis, this is only exponent, right? So this equals 1. However, this one, we don't have parenthesis. We have to consider 11 to the 0th power first, then multiply by -1. So answer is what? -1. Do you see that? Alright, so now let's look at this question. 0 to the 5th power divided by 5 to the 0th power. Zero to the 5th power.
Is that 0?
Yeah. 5 and 0 multiplied by together is 0. What is 5 to the 0th power?
1.
So 0 over 1 equals what? 0. So 0 as exponent, we have to be careful. Only when the base a is a non-zero number, the 0th power is 1. Otherwise, 0 to the nth power is what? 0, okay? Alright, now let's look at the negative exponent. We say a to the -mth power equals what? 1 over a to the mth power. Remember this, please, okay? A to the -mth power equals 1 over a to the positive nth power. So say, for example, what is 2 to the -3th power? According to the definition, it should equals what? 1 over 2 to the what? Positive 3's power. Okay? What is 2 to the cube? What is 2 to the cube?
8.
8. So 1/8. Right? What is x to the negative 9's power? 1 over x to the 9's, right? What is a to the negative 2, b to the negative 3, c to the negative 1? 1 over a squared times 1 over b to the cube times 1 over c. Eventually, numerator times numerator give us 1. Denominator times denominator give us the denominator. Right? So that's good, everybody? Right. I will give you a couple minutes to try the D, E, and F. This is negative 3, okay? This is negative 2. Yeah. Try these 3 and then I'll show you the answer. Let's look at D. Have you tried D? 1 over a to the negative 4. 1 over. What is a to the negative 4? Equals 1 over what? A to the positive 4's power, right? A to the negative number can be written by 1 over a to the positive exponent, right? So a to the negative 4, 1 over a to the 4, right? So 1 over 1 over a to the 4's power. Actually, we should get what? 1 divided by fraction can be written by multiply this fraction, flip upside and down, right? So eventually, answer is what? A to the 4's power, right? You agree with this question? Everybody? How about E? 3 to the negative 2 should be written by 1 over 3 to the what? Positive 2's power, right? Times by x squared times y times by, what is z to the negative 1/3? Z to the negative 3. 1 over what? Z to the 3, right? So, 3 squared, we know it is 9, okay? Yeah, this is x squared over 1, y over 1, okay? So we have 4 fractions multiplied by together. Numerator times numerator, we should have x squared times y. On the denominator, we should have what? 3 squared is what? 9 times z to the cube. Come on? Got it? Alright, question F. We have a fraction, okay? Then we have these factors, okay? So what do? We do it one by one. Do it one by one. 2 times by, what is x to the negative 3? over x to the 3 times y times 1 over what? Z, you guys, right? And then this becomes 1 over w to the 5th times by what? V to the 7th. So far so good, everybody? Okay, now let's do it this way. Okay, on the top of the fraction, we will still have 2 times y, right? 2 times y. How do we deal with this 1 over x to the cube? This can be written by what? 1 over x to the cube. This can be written by 1 over z. So I put these two on the bottom of the fraction. Okay? Now, on the bottom we have a 1 over w to the 5th. Okay? Remember, if you have a 1 over something on the bottom, eventually it's equivalent to what? We flip the a to the 4th power up to the numerator, right? So this is what? This is 1 over w to the 5th. So we can flip the w to the 5th to the top of the fraction, right? And then v to the 7th is still on the denominator, so we keep the v to the 7th. Okay? Well, guys, let's compare the original expression and the result. This is the result. Let's see what we can get. 2 is number 2. We don't change it. Actually, negative 3. If this is a negative exponent, we can flip it to the what? Bottom and have a positive exponent, right? Do you see that? Y's first power, this is not a negative exponent, we keep the y. Z to the negative 1, okay, negative power, we flip the z to the bottom, which has a positive first power. W to the negative 5 is a negative power. We can flip w to the top and make it have a positive what? Exponent. V to the 7 is still v to the 7. Guys, do you see that? So later, we don't have to do it this way. What do? Oh, if we have an x to the negative 3, we can flip the x to the bottom and then let it have x to the 3, right? This is negative 1. Oh, this to the first one on the bottom. W to the negative 5, flip it to the top. We have a w to the 5th. Do you see that? The rule? Alright, very good. Okay, very good. Alright, now let's move on to the next page. Okay, to the next page. Let's try this one. Write x to the 7th over x to the 4 in the factored form. X to the 7th. How many x multiplied by together? 7, right? 2, 3, 4, 5, 6, and 7. X to the 4th power. Y, 1, 2, 3, and 4. Right? So can we simplify this expression? X cancel out. 4 of x cancel out. So eventually there are only what? 3x multiplied together, which is x to the cube. Okay? So now write that in simplified exponential form. Okay? Yeah, in factor form it is this. In simplified form it is what? X to the cube. So what did you notice about this simplified version? We have x to the 7th over x to the 4th power. We eventually get x to the 1 cube, right? So now we have our quotient rule. A to the mth power divided by a to the nth power will equals what? A to the m minus nth power. Okay, this is called a quotient rule. That means when we have a division, we have the same base. We keep the same base a, and then we subtract what? The power. Okay. All right. So let's try to look at some question. Okay, let's look at some question. Okay, I would say let's try question D and F together. X to the cube, y to the 4th power, divided by x to the cube, times y to the 6th. This equals what? X to the cube over x to the cube. What? Cancel out, right? Gone. Y to the 4 divided by y to the 6, we should have what? Y to the what? 4 minus 6, right? Is it 4 minus 6? Yeah, y to the negative 2, and we write it in as a positive exponent. We should get y over what? 1 over y squared. Done. You guys? Now let's try number F. 2 to the negative 7, 2 to the negative 2. What should we do? Which rule are we using? Quotient rule. Keep the base 2. Use the upper exponent negative 7 minus the lower exponent, which is negative 2. So we should get 2 to the negative 7 minus become what? Plus. Right? Right, Jose?
Yeah.
Okay, and then this equals what? 2 to the negative 5th power, and then it becomes 1 over 2 to the 5th. 1 over, what is 2 to the 5th power? To the 4th power is 16. 2 to the 5th equals what? 32. Right? 132. You guys, so far so good, everyone? Alright, now this question is put all of the rules together to simplify the following expression with positive exponents eventually. Okay, I want to do some of these questions and I will let you try some. Okay, let's try D, G, and I. Let's look at D first. Yeah, we may want to talk about H as well, okay? Negative 2 to the a to the negative 4b negative 3's power. How can we simplify this expression? Do you see the negative 3 the power? So when we have a power outside the parentheses, remember in section 5.1, what did we learn? Which rule should we use? Remember that? Remember this rule? A times b to the m's power equals a to the m's power times b to the m's power, right? So that means we distribute the power m to each factors inside of the parentheses, right? So, for this question B, how many factors are inside of the parentheses? We have a negative 2, right? We have a to the negative 4th power. We have a b, right? So now we're going to distribute the negative 3's power to each of this factor. What do you think? Distribute the negative 3's power to each factor from the parentheses. Now let's see. What is negative 2 to the negative 3's power? By using the negative exponent, this equals what? 1 over negative 2 to the 1? Positive 3, right? How to compute a to the negative 4 to the negative 3's power? Which rule should we use? Check the previous rule we had learned. Power rule, right? A to the m's power, then n's power equals a to the what? M times n's power, right? So here we should have a to the negative 4 times negative 3 give us what? 12's power, right? And then b to the what? Negative 3's power. Alright, so negative 2 to the 3's power, what is it? This is negative 8, right? Negative 1 over 8. Agree with that, right? times by a to the 12s, okay, times by b to the negative 3. What is b to the negative 3? This can be written by b to the negative, yes, this is a to the 12 over 1. b to the negative 3 over 1. Remember, if you have a negative exponent, we flip, right? We flip it on the bottom. We have a b to the cube. Why we're doing this? Because now we're having a to the 12th power, b to the cube. All of these exponents, they are positive exponents. Eventually, see, guys, we have to make sure our expression only will have positive exponents. If we're still keeping negative exponents, we have to rewrite it in terms of positive exponents, okay? Are you ready to look at the question G? 3xy square. 3xy square. Same base, right? So this division, what should we do? Remember the quotient we just learned, right? Same base division, we keep the same base and we subtract the exponent, right? So same base, 3 times x times y square, and then we use what? The top exponent minus what? The bottom exponent. That will give us 3xy square to the what? What is negative 3 plus 4? Minus negative 4 means negative plus 4, right? First 4 power, right? So eventually answer is what? 3xy square. No negative exponent, right? See about question H. 4 squared times 2 to the negative 3. Are we able to multiply these two together? No, they do not have the same base, right? However, 4 can be written by what? 2 square, right? Yeah, 4 can be written by 2 square. Base square. 2 to the negative 3. By using the power rule, 2 to the 1. 2 times 2 gives us what? 4. 2 to the negative 3. And then we use what? Product rule, right? Same base 2. Add up 4 by negative 3. 2. You guys, was good? Alright, this last the question. 3 times x to the 5th times y to the 6th divided by z squared to the negative 3rd power. How can we do this problem? Any suggestion? Jose?
We want to do same thing that we did for D. So it will be 3 in the parentheses with -3.
Okay. So we want to distribute the negative 3 to each of the factors in a fraction, right?
Okay.
So let's do 3 to the negative 3, x to the 1st to the negative 3, y to the 6 to the negative 3, divided by z squared to the what? Negative 3. Right? Can we? Yes! And then 3 to the negative 3, let's just still keep it, okay? X to the 5th, then to the negative 3 gives us negative 1. 15. Y to the 6 to the negative 3, negative 18. And then z to the 2 times negative 3, 3 give us what? Negative 6. Can we say this is our final answer? No. All of these exponents, they are negative, right? So we have to rewrite them, okay? 3 to the negative 3, negative exponent, flip 3 to the cube on the bottom. X to the negative 15, flip it on the bottom, x to the 15. Y to the negative 18, flip it on the bottom, y to the positive 18. Z to the negative 6, flip it to the top, give us z to the 6, right? And then you can write, what is 3 to the cube? 27, right? So answer is b to the 6 over 27 times the x to the 15 times by what? Y to the 18.